Welcome to Simplifying Radical Expressions with Variables, Enrichment. It says at the top here, the information below is enrichment. Let's take a closer look. It says the properties of rational exponents and radicals can also be applied to expressions involving variables. Because a variable can represent a positive number, a negative number, or a zero, sometimes absolute value bars are needed when simplifying a variable expression. Remember, when n is even, we always assume we are finding the positive or principal root. Therefore, and this is the important part, if the index is even, right, if it's a square root, fourth root, sixth root, and there's a variable under the nth root, we're going to need to put absolute value bars around the simplified expression to make sure that the variable that's outside the root represents a positive number. Okay, so looking down here when it says when n is odd, we don't have to worry about anything, right? We could just take the seventh root of 5 to the 7th and get 5. Or we can take the seventh root of negative 5 to the 7th and get negative 5. Okay, there's no problems when n is odd. The problem arises when n is even. If n is even, if we're taking an even root, notice how your answer is going to have absolute value bars around it. Right? The fourth root of 3 to the 4th is 3. But what is the fourth root of negative 3 to the 4th? It's not negative 3. You can't take a fourth root of a positive number and get a negative number. Okay, so what we need is around our answers, we need to put those absolute value bars to make it a true statement. Right? Really, this would be the fourth root of what is negative 3 to the 4th power? If I put that in my calculator, you end up getting 81. And we know that the fourth root of 81 is just going to be 3. Okay, so you need to make sure you put absolute value bars around your answer to get an answer of positive 3. Again, absolute value bars are not needed when all the variables are assumed to be positive, which for the purpose of a CP course, we're just assuming variables are going to be positive for most of our problems that we work with. Okay, but I think that it's important if you're, trying to get into calculus in the future that we talk about these enrichment examples where you might need to put absolute value bars in your solutions. Okay, notice in the directions here, it just says simplify each expression. It doesn't talk about all variables being positive. So if it doesn't tell you that all variables are assumed to be positive, then we may need absolute value bars in our answer. Looking here, instantly I see that we have an odd root. So do I have to worry about anything? No, I don't have to worry about any absolute value. I just simplify. What is the cube root of 64? That's going to be 4. And what is the cube root of y to the 6th? 6 divided by 3 would be 2. And you'd be done. Here, do I need to worry about absolute value? Yes, we have an even root, right? Even root may mean that we need absolute value bars in our answer. So 4 divided by 4, we get x to the 1st. 8 divided by 4, we get y squared. And so really I should be looking at writing my answer like this, where I've got absolute value around both expressions. Okay, now I'm going to tell you, you don't need absolute value bars in the denominator. Why? Why is that? Well, it's because if I've got y squared in the denominator, I already know that that expression is going to be positive. Whether y represents a negative number or a positive number, it's not going to matter because once I square it, the expression is going to be positive. So that's all I have to write there. And the next one, do I have to worry? Yes, it's a square root, right? It's an even root. So you might need absolute value bars. Okay, 6 divided by 2 is going to give me y cubed. Again, I need to make sure that whatever y is represents a positive number. Okay, so we need absolute value bars there.